Problem number 5, solve by substitution. Now we remember that when we solve by substitution, we first need every problem to have an isolated variable. Not every problem. One of our problems to have an isolated variable. Problem 5 has two isolated variables. So we know that y is equal to 2x plus 10, and we know that y is equal to negative 2x minus 6. Now on this particular problem, we talked a little bit about logic in class. And we talked about the logic where a is equal to b, and b is equal to c. Logically, c would have to be equal to a. The same sense of logic applies to this particular problem. If y is equal to 2x plus 10, and y is also equal to negative 2x minus 6, then it must be logically true that 2x plus 10 is equal to negative 2x minus 6. That's one way to set up the problem. Another way is to be consistent in circling our y's. And since y is equal to 2x plus 10, we're going to substitute that in for y. So, instead of rewriting y, I'm going to write what it's being substituted with. 2x plus 10 is equal to, and now we just finish out the rest of the original equation. Negative 2x minus 6. Where I'm first going to isolate my variable, or get it all onto one side. And I'll accomplish that by adding 2x to both sides. So 4x plus 10 is equal to negative 6. And then we will subtract 10 from both sides. 4x is equal to negative 16. And then we'll divide by 4 on both sides, where x is equal to negative 4. Well, we now know the value of one of our variables. One of our variables has an x value of negative 4. We can take that x value of negative 4 and plug it into our equation and solve for the y value. So, I'm going to use my bottom equation here. Y is equal to negative 2 times x. Well, we just learned that the value of x is negative 4, so that's what I'm going to plug in for x. Minus 6. Negative 2 times negative 4, well, that would be positive 8 minus 6. And now we end up with 8 minus 6 equaling 2. So our y value is 2. Now, I talked in class about how you can check every solution to verify that you did all of your work correctly. We take this ordered pair that we just said was the solution to our system, and we plug it into both equations. So my first equation, y equals 2x plus 10, where my y value is 2. My x value is negative 4. 2 times negative 4 is negative 8. Negative 8 plus 10 is in fact 2. 2 does equal 2, so that ordered pair satisfied that equation. Now we take our next equation. Y equals negative 2x minus 6, where my y value is 2, and my x value is negative 4. Negative 2 times negative 4 is positive 8. 8 minus 6 is 2. 2 again does equal 2, so that also checks out. That ordered pair will be present in both the top equation and in the bottom equation, and thus be a solution to the system of equations. Problem number 6. I don't have an isolated variable in either equation, so now you need to isolate the variable first before we can use the substitution method. Negative x plus y equals 4. So I'm going to add x to both sides, where y will then equal x plus 4. Well, now we can apply our substitution method. We have a y as our isolated variable being equal to x plus 4. We're going to plug that in for y right here. So we rewrite our bottom equation. 3x minus 2 times my y value, which we just said was x plus 4, equals negative 7. Now, you should remember back from your equations, expressions, inequalities unit last year in 6-7, and one of the things that tends to catch students quite often is a subtraction sign in front of an integer in front of a parentheses. And most of my students have been taught to change that to an addition sign using the additive inverse rule. So you will add the opposite. That just helps us to remember we have a negative 2 sitting in front of the parentheses. It's the negative 2 that's getting distributed through the parentheses. So 3x plus negative 2 times x, which is negative 2x, plus negative 2 times 4 is negative 8. I'm going to put those in parentheses so I don't forget their negatives. So we have 3x plus negative 2x, positive and a negative. Find the difference between the two. Keep the larger absolute value number. So that's the same as subtracting the 2. 3 minus 2x is just x by itself. Plus negative 8. That's the same thing as saying minus 8 equals negative 7. So now I add 8 to both sides, and x is equal to 1. Now that I found my x value, I want to find my y value. So I'm going to take that x value and plug it into one of my equations. Negative x value of 1 plus y is equal to 4. Note, this is not saying that the x value is negative 1. It's saying that we're taking the opposite of whatever x is, the opposite of 1, so we end up then with negative 1. So opposite of 1 is negative 1 plus y equals 4. We add 1 to both sides, and y then is equal to 5. Our solution for this system, 1, 5. Now again, you can check the system of solutions. I'm not going to do that here for you now. I showed you how to do that for problem number 5. You should be able to do the same thing for problem number 6. I'm going to move on to problem number 7. Problem number 7, x is equal to 7 minus 2y. 2x plus y is equal to 5. Now, quite oftentimes I end up with students that will take the bottom equation and subtract 2x from both sides to isolate the y. There's really no need for that because we already have an isolated variable, and that isolated variable is x. X is all by itself, so I can circle it in both equations. And that means that x is equal to 7 minus 2y. Well, since x is equal to 7 minus 2y, we can substitute that in 2 times whatever x is equal to. And we finish with the rest of the equation. So now I need to distribute. 2 times 7 is 14 minus 4y plus y is equal to 5, where I will subtract 14 from both sides. Negative 4y plus y is equal to negative 9. Well, negative 4y plus y is just negative 3y. And we'll divide by negative 3. And y then is equal to 3. Well, now that we know the value of y, we can plug that into one of our previous equations and figure out the value of x. Since my first equation has x all by itself, I'm going to use that particular equation. X is equal to 7 minus 2y. So x is equal to 7 minus 2 times the value of y, which is 3. So x is equal to 7 minus, notice I'm just doing order of operations here now. 2 times 3 is 6. So x is equal to 7 minus 6, which is 1. So our system solution would be 1, 3. Again, you can plug those in to check your answers. Problem number 8, solve by elimination. Show your work and check your solution. Now, the elimination method requires us to have opposite coefficients for at least one of our variables. Looking at problem number 8, I can already see that I have a y value that has a coefficient of -2 and a y value that has a coefficient of 2. Those are opposite coefficients. So I can add my two equations together and one of my variables will eliminate itself. So I have x plus 5x, that becomes 6x. -2y plus 2y, well that's just plus 0, equals -19 plus 1, which is -18. This is really one of the preferred methods of solving systems because it's so much quicker and ends up with a lot less work than you saw up here in problems 5 through 7. So 6x plus 0 is just 6x equals -18. We'll divide by 6 on both sides, and x is equal to -3. Now that I know my x value, I can solve for my y value. I'm going to take that x value and plug it back into one of my equations. -3 minus 2y equals -19, where I will add 3 to both sides and end up with -16 is equal to -2y, and I'll divide by -2. Y will be equal to +8. So our solution is going to be -3, 8. Again, you can check your solutions to these the same way that you checked your solutions for substitution. You take your -3 and your 8, you plug them in for x and y. Number 9. Number 9 is where elimination becomes a degree more challenging. I don't have an opposite coefficient in either equation. And not only that, I don't have a coefficient that's going to have a quick, clean, easy multiple. In other words, I can multiply one equation and end up with an opposite coefficient. This one's going to require me to multiply both the first equation and the second equation by some value that will allow me to clear out a variable. Now I can see that my y coefficient is negative and my y coefficient is positive. So they're at least opposite of each other, just not opposite of the same value. My x is the same as true also. I have a positive and negative. I'm generally going to prefer to deal with the smaller numbers if possible, because that's going to keep the rest of my numbers from getting very large. So here, in order for me to have a common factor, I'm going to multiply by 3. And I multiply 3 times 2x, which gives me 6x. Plus 3 times 5 is going to give me 15y. Plus 3 times 26, which is going to give me 78. Well, that is great and puts us in the right direction, but we still don't have a coefficient that is opposite of each other to be able to isolate. So I'm going to have to multiply my second equation, And this particular one, I can multiply by 2. 2 times negative 3 gives me negative 6x. So now we should see, oh, my x's are going to clear out. 2 times negative 4 becomes negative 8y equals 2 times negative 25 is negative 50. And we will combine 6x and negative 6x is 0. 15y and negative 8y would be negative 7y. Sorry, positive 7y. 78 and 50 is going to give us a positive 28. By now we should be starting to see the solution, but we'll keep solving. 0 plus 7y is the same as 7y, which equals 28, where we'll divide both sides by 7, and y will equal 4. Well, now it doesn't matter which equation I plug the y back into, since we manipulated both of them to be able to solve this system. But I'm going to go ahead and work with top one because it's got all positive variables, which will make it a little bit simpler. 2 times x plus 5 times y, we know the y value before, equals 26. 5 times y is 20. Oh, sorry, 5 times 4 is 20, which equals 26. We'll subtract 20 from both sides. So 6 is equal to 2x. We'll divide by 2 on both sides, and x will be equal to 3. We now know the value of x. We now know the value of y. Our solution, 3, 4. Again, we can check our answers by taking that solution, plugging it into both of our equations, and make sure that we have values that equal each other at the end of solving those. Number 10. We got an opposite coefficient for both of our x's. One x has a 1, the other x has a negative 1. So when I add those two together, they're going to cancel out. Negative x plus x is 0. 1y plus negative 5y. So negative 4y equals 5 plus negative 9, which is negative 4. So negative 4y equals negative 4, where we'll divide by negative 4. And y will be equal to 1. Well, now that we know that y is equal to 1, we'll plug that in. Negative x plus our value of y, which we just said is 1, equals 5. We'll subtract 1 from both sides, and negative x will be equal to 4. The only problem is I don't want to know the value of negative x. I want to know the value of x. So I'm going to divide, or you can multiply by negative 1. And that will give us x is equal to negative 4. So our solution is going to be negative 4, 1. And we move on to the next section.